Today, we are performing a structural audit of the $600 billion cloud. Most believe the internet is virtual, clean, and weightless, but it is actually a high-pressure furnace cannibalizing the global grid. As a mechatronics professor, I know exactly how these machines fail. I am revealing the industrial blueprint big tech is hiding from you. Marketing experts stole a word from the sky to hide a factory. Amazon launched Elastic Compute Cloud in 2006. They realized server farm sounded dirty and mechanical. Cloud sounded infinite, soft, clean. Think of it like a steam locomotive wrapped in a silk curtain. Data centers are brutalist fortresses of concrete and copper. Microsoft and Google are now heavy industrial landlords. Combined capital expenditure for 2026 will hit $600 billion. Physical land and high-voltage substations consume most of that budget. These are not office parks or tech campuses. They are gigawatt-scale industrial zones. One facility in Nevada spans 7 million square feet. That is larger than the Pentagon building. Before the cloud, computing lived in office server closets. It was a decentralized and messy reality. Hyperscalers centralized this power into massive concrete bunkers. They moved the mess out of your sight. They replaced the hum of fans with a digital interface. But the physics did not vanish. The noise just moved to Loudoun County. But the concrete isn't the bottleneck. It's what happens when the thermal load starts to spike. Physics dictates the design of every server room. Electricity converts entirely into raw heat. Air cooling worked for decades. Massive fans moved chilled atmosphere through the racks. Imagine trying to cool a nuclear reactor with a desk fan. Modern AI server racks now draw 140 kilowatts. Air literally stops working as a cooling medium at this density. Flow rates would need to be supersonic to remove that heat. The fans would scream at a deafening pitch. They would consume more power than the servers themselves. The machine would enter thermal runaway and melt. The industry is forced to use liquid-to-chip manifolds. Water has 3,500 times the heat capacity of air. Modern data centers are now plumbed like oil refineries. Precision-machined cold plates sit directly on the silicon. These racks weigh 2,500 pounds. That is more than a standard passenger car. The thermal flux on a modern GPU is extreme. It rivals the heat at the surface of the sun. We are fighting a war against the laws of thermodynamics. Every bit of data requires a physical cooling debt. If you had to cool a megawatt in one room, would you trust a fan or a pipe? We'll look at the water cost next, but first, you need to see the electrical debt keeping these racks alive. Uptime is the only metric that matters in this industry. Tier 4 certification requires 99.995% reliability. Your local electrical grid is never that stable. Everything I just told you, it's actually about something much bigger than your data. It's about who commands the national grid. Every hyperscale campus is its own sovereign power plant. The power enters at 34,000 volts. Huge on-site transformers step it down to 480. This is a violence of voltage tamed by copper and oil. Rows of 3-megawatt diesel generators surround the server halls. A grid failure starts a violent mechanical sequence. Massive lithium-ion batteries take the load in 10 milliseconds. This is the double conversion UPS system. It converts AC to DC and back to AC. This filters the dirty power from the grid. The automatic transfer switch sends a start signal immediately. Generators must hit 1,800 revolutions per minute in under 30 seconds. Cloud providers store hundreds of thousands of gallons of fuel. They have priority refueling contracts during national emergencies. This is not a green digital service. It is a fossil fuel engine sitting in a state of constant readiness. If you're starting to see the machine behind the marketing, it helps the channel grow to share these system-level breakdowns. Big tech shouts about net zero targets and green initiatives. They use renewable energy certificates to balance the books. RECs are a paper shield for a coal-fired reality. A data center in Virginia draws massive power from the grid. That grid is fueled by natural gas and coal. The operator buys wind credits from Texas to offset the load. This is a feedback loop of creative accounting. A 2024 study revealed the uncomfortable truth. Actual emissions are 662% higher than reported. These companies match their annual usage. usage, not their hourly demand. The sun sets, but the cloud never slows down. When the wind stops, the coal must burn. The accounting tricks don't stop the carbon from entering the sky. They just hide the mechanical cost from the shareholders. Many facilities are now building private gas-fired power plants. They cannot wait for the grid to upgrade. They are bypassing the public utility entirely. This is the industrialization of intelligence. But even the carbon isn't the immediate threat to the system, it's the evaporation. Thermodynamics offers no free lunch to any engineer. Cooling requires either watts or water. Evaporative systems are highly efficient but extremely thirsty. Google's facility in Iowa consumed 1 billion gallons of water in a year. This is potable water diverted from local drinking supplies. Communities in Chile and Arizona are fighting back. They realize the cloud is a direct competitor for their survival. If you use less water, you must use mechanical refrigeration. That requires exponentially more electricity from the grid. There is no clean way to reject a gigawatt of heat. Microsoft and Google exhaust heat into the local atmosphere. This creates heat islands around the data center campuses. The fans are deafening for residents living nearby. Noise levels often exceed 70 decibels at the property line. Where would you place the constraint? Do we burn more coal or evaporate more drinking water? Let's zoom out to the global infrastructure. The internet is connected by 1.5 million kilometers of cable. These are submarine fiber optics resting on the ocean floor. They are the diameter of a common garden hose. Inside is a core of pure glass the size of a hair. They descend to depths of 8,000 meters. The internet is a stress fracture across the tectonic plates. If a ship anchor snags a cable, a continent goes dark. This happened in Tonga during a 2022 eruption. The nation was disconnected from humanity for weeks. We think our data is broadcast through the air. It is actually pulsing through glass tubes under the sea. Every 100 kilometers, there is a repeater. These repeaters amplify the laser light using erbium-doped fiber. These repeaters need constant high-voltage electrical power. The cables are armored with galvanized steel wire. They are buried in the seabed by robotic underwater plows. Inside the data center, copper is making a massive comeback. High-density AI racks need massive copper bus bars for power. Copper demand for data centers will hit 1 million tons by 2040. The cloud is not a digital transition. It is a commodity-hungry industrial revolution. Northern Virginia is the capital of the physical internet. 70% of global traffic passes through this single region. Loudoun County is the most important industrial node on Earth. Power demand there will hit 13 gigawatts by 2038. That is the generating capacity of 10 nuclear reactors. Dominion Energy is struggling to build transmission lines fast enough. In Dublin, data centers consume 79% of the city's power. The grid is buckling under the weight of the machine. This is not a software problem. It is a civil engineering crisis. We are building a system that cannibalizes the infrastructure of cities. Big tech is effectively colonizing the global power grid. They are buying up stranded power across the world. They find cheap electricity and build a wall around it. And this leads us to the final realization about who really runs this machine. Look at Elon Musk's XAI Colossus build in Memphis. They deployed 100,000 GPUs in just 122 days. This is an unprecedented industrial speedrun. They needed 150 megawatts of immediate power. They used mobile gas turbines because the grid was too slow. This is the brute force phase of the cloud. We are no longer optimizing for efficiency. We are optimizing for sheer industrial volume. The machine is growing faster than the regulatory system. It is growing faster than the green energy transition. It is a thermodynamic engine that cannot be stopped. Stop looking at the sky when you hear about the cloud. It is a fake framing for a dirty industrial age. The cloud is concrete. It is copper. It is a thermodynamic furnace with $1 trillion budget. We are building the largest machine in human history, and we are calling it a cloud so we don't feel the weight. Does the internet serve the grid, or is the grid now just a power supply for the machine? Did the cloud save us from hardware, or just hide the industrial collapse?